Hey guys, today we're talking about properties of logarithms. So we're going to let a, u, and v be positive real numbers such that n is not equal to 1. It should be n, u, and v. And let a be any real number. Then the following are true. Let's look at these one at a time. The log base n of u times v is the log base n of u plus the log base n of v. The log base n of u divided by v is equal to the log base n of u minus the log base n of v. And the log base n of u to the a power is equal to a times the log base n of u. Okay, so make that n. And yeah, there we go. Okay, so, or not, I'm sorry, that should be a. No, that's it. Okay. Be very careful, though, because you cannot simplify log base n of u plus v. Okay, so basically I can take these and break them up. An example of this would be if I had the log base 2 of 6, I could break that up if it was more convenient for me to be the log base 2 of 2 plus the log base 2 of 3. Okay. And likewise, if I had the log base 4 of x over 9, that would be equal to the log base 4 of x minus the log base 4 of 9. And if I had, say, the log base 3 of x to the 4th power, I could make that 4 times the log base 3 of x. Okay, so that comes in handy for us a bunch of times. Okay, so what we're going to do is we're going to use the log base 10 of 2 is approximately equal to 3.01. The log base 10 of 3 is approximately equal to 0.477. We use that to approximate the log base 10 of 2/3. Okay, so what I can do here is I can use this property, one of those properties, to say, you know what, the log base 10 of 2/3 is equal to the log base 10 of 2 minus the log base 10 of 3. And now I know that the log base 10 of 2 is 0.301, and the log base 10 of 3 is 0.477. And so I can just go ahead and subtract that. 0.301 minus 0.477 would be negative 0.176. Okay, so I'll let you pause the video right here and try these two out and see what you get, and then jump back on and compare it to what we get. Okay, this one here would be the log base 10 of 2 plus the log base 10 of 3, because 2 times 3 is 6. And so this would be 0.301 plus 0.477. That's going to equal 0.778. And then this one here, we could change this to the log base 10 of 3 squared, which would equal 2 times the log base 10 of 3, which would be 2 times 0.477, which would be approximately 0.954. Okay, so hopefully you got both those correct. All right, use the properties of logarithms to rewrite the log base 10 of 7x to the third power. Okay, so I can write that as the log base 10 of 7 plus 3 times the log base 10 of x. Okay, so since I got multiplication, I can break these two pieces apart and add them together. And then since this is x to the third power, I can take the power down in front and make it 3 times just the log base 10 of x. Okay, condensing the log base 2 of x minus the log base 2 of 3. So I can condense those, log base 2, and it's going to be, since the subtraction is going to be division, this is my numerator, that's my denominator, so that's going to be x over 3. And I'm done. Piece of cake. Expand. The log base 6 of 36xy cubed. Okay, so that's going to be the log base 6 of 36 plus the log base 6 of x plus 3 times the log base 6 of y. Now, I can simplify this because the log base 6 of 36, remember this is 6 to some power equals 36, that's going to be 2. So this simplifies to be 2 log base 6 of x plus 3 log base 6 of y, and I'm done. Okay, condense this. The log base 4 of 8 minus the log base 4 of x plus 5 times the log base 4 of y. Okay, so this is going to be all log base 4. And I'm going to have a numerator and a denominator because I got division here, I got multiplication here. So this is going to go on top, that's going to be 8. This is going to go on the bottom, that's going to be x squared. This is going to go on the top, y to the 5th power. And there you go, it's all condensed. Now, anything that you're adding here is going to go in the numerator. Anything you subtract is going to go in the denominator. Okay, the Richter scale. The Richter scale is used to measure the magnitude of an earthquake. The magnitude R of an earthquake of intensity I is given by R equals the log base 10 of I, where the intensity is the measure of the wave energy of an earthquake per unit of area. Okay, we got a picture here of the Great Alaskan Earthquake of 1964. It reached 9.3 on the Richter scale. Find the intensity of the earthquake. Okay, so we're going to go back to this formula. So, 9.3, that's the Richter scale, is going to equal the log base 10 of I. Now, how do we get rid of a log? Well, remember, logs and powers are inverse of each other, so I'm going to go ahead and go 10 to both of these powers, and that will cancel out this right here, and I get I equals 10 to the 9.3 power. So I get out my calculator, 10 to the 9.3 is one very large number here. Okay, so we got what? 1,995,262,315 on the intensity. Okay, now the San Francisco Bay earthquake was only a 7.1, only a 7.1. That was a huge earthquake. That's going to equal the log base 10 of I. So I'm again going to go 10 to those powers. That's going to cancel out that, leave me with I is 10 to the 7.1 power. Okay, so that's going to be 1, 2, 5, 8, 9, 2, 2. Okay, so that's going to be 12,589,254.2. So the final question is, how many times bigger was the Great Alaskan Earthquake than the San Francisco Bay Earthquake? So I'm just going to take this and divide it by that. So 5 divided by 12,589,254.2. And that's going to come out to be 15.84 times as big. Okay, so here's the assignment for you. I will see you next time. Have a great day.
You want them to put their stuff in